Hello everyone and welcome back to the Leetcode Grind. Today we have 416 partition equals subset sum. This is a problem that's being asked by Meta for an on-site interview. It says here, given an integer array nums, we are to return true if we can partition the array into two subsets such that the sum of the elements in both subsets is equal, or false otherwise. So given some input, let's make that a bit bigger. Given some input, we say this is true if the sum is going to be 1 plus 5 is 6, plus 11 is 17, plus 5 is 22. So the total is 22. For this to be evenly partitioned into two subsets such that the sum in both subsets is equal, for that to happen, each subset must equal 11, which tells you that whatever input we receive, if the total cannot be evenly divisible in half, if there is a remainder, if it cannot be evenly divisible, then right off the bat, we know that this will return false. Okay, so that's the first thing. And the other thing is, in terms of the strategy of trying to determine if this is evenly divisible, so it's easy to tell if it's false. So, we can return that. But how to determine if it's true? Well, we can use the approach of iterating through each value and determining whether to use or to skip the current value. Okay, so in this case, we already have the answer. We know that 11 should be by itself and that we should be grouping these three into one subset. So we would be arriving at this index and we would say, do we use or skip given that we're trying to reach this value? So if we use, then the remainder becomes 10 because we subtract 1 from our target 11, thereby returning 10. And we're kind of peeking backwards, but we know we want to use it. So if we use it, then this is our current remainder. Remainder minus 5 is 5. We know we want to skip this, but let's say we didn't skip it. Well, 5 minus 11, that's going to be minus 16. So because it's less than 0, this is just off limits. So we skip this guy, and then we know we're going to use this guy. Once we do, the current remainder, 5 minus the number that we are deciding to use, well, look at that. That becomes 0. And that's the strategy we can use to see if there are any numbers that we can use from here in order to, tabulate up to the half of our total. Okay, so let's implement that in logic here. We do have some DFS helper function, which takes in some remainder and then the index to explore. And our base condition was if the remainder is, well, before we do that, let's say, okay, so we have a variable to hold the total count of numbers and another to hold the sum of adding up all of these numbers. And then remember, we want to check if the total modulo 2 is 0. This must first be true, meaning that this total must be evenly divisible by 2. And then there's another condition. But if it's not evenly divisible by 2, then we know we can never satisfy this condition, so we can return false right away. So we're checking that this is true and DFS of, remember our goal is to get half of it using the numbers here. So we search total in half, and we start our search from the first index, index 0. Okay, so this is what we're returning. Now for the actual DFS function, we say our base condition is if the remainder is exactly 0, then we reach this case where we found all the numbers and we can return true. Now let's say that the I is greater than or equal to n, meaning that we've actually gone past this array without reaching 0, then we return false. Another case where we return false is if the remainder is actually less than 0. So that would be this scenario where if we decided to use 11, then 5 minus 11 would be negative 16. Or sorry, 5 minus 11 is actually negative 6, negative 6. So that would be less than 0, and so that would also be false. So return false. And here, our use situation is if we use the current number, so we return, if we use or if not use. Now for the if use, we're calling DFS with the remainder minus the nums at this current index that we're looking at. This is if we use it, then we subtract it from the remainder and continue our search into the next guy, the next number. Otherwise, if we don't use, our remainder stays intact, nothing was used up, and then using our, preserved remainder, we continue our search into the next index. All right, let's give that a go and submit. And this won't work because we need caching. The quick trick is actually just to add this decorator. If we do that and submit, it does work. Now, if you don't want to use this, it's actually quite simple. All we do is have, let's say, a map and say, you know what, is this remainder at this index, has this condition, this state been explored already? Is it already in cache? If so, then return cache at that state. If not, we'll continue our logic here and say whatever this ends up being that we're returning, let's, instead of returning it, let's actually store it in our cache and then return what we have stored. And that's pretty much it. Let's give that a go. There you have it. That was once again 416 partition equals subset sum. Thanks so much. Happy coding. See you next time.